Alright, here I am doing the second part. I've just sketched in some of this to get us started. An example of skewed right is when your bell-shaped curve has been pulled and stretched out to the right. It's not when the bump is to the right, it's when the thin part is to the right. Okay, so then on to this one. If the scores on a math quiz are normally distributed, it means that you're getting this bell-shaped curve. We're allowed to apply our rules of standard deviation. Remember that 34, 13.5, 2.35 rule. You can write that down at the top of your test. 34.0, 13.5, and 2.35. Then this will be 34%, and this will be 13.5, and this will be 2.35. Okay, then you put in the numbers. Every standard deviation, you're going to go and draw a line. So in this case, the standard deviation, it says so up here, it's 8. So I'm adding and subtracting 8 from my X bar value. Now just answer the question, what percentage of students score above an 80? What percentage of students are up in here? That's really what they're asking. The easiest way, if you're going towards the thin tip, is to ask what's the rest down here. This is the line that divides it by 50%. This side is 50%, this side is 50%. So I take away 30 from my 50%, and that's got to be what's left up here, and that's 16%. Okay, that's part A. Part B then, if there were 22 students, I'm going to take 22 and I'm going to multiply that by the percentage that score between 56 here and 80 up here. Well, that's just 13.5 plus 34 plus 34. That's 68. That's 81.5. So 80.815 is my percent as a decimal, and I'm just going to do the math. I'll let you type it in. All right, I'll take 2 seconds. And I get 22 times 0.815, and it is 17.93. So you'd say approximately 18 students. All right? There's your answer. Now here's the final problem. Given the following data set showing the numbers of attempts versus the actual three-pointers made by, let's not say the Celtics, let's say maybe it's Justin or somebody, all right, over the last 10 games, all right. Here we go, 20 attempts and 11 shots made, 18 attempts, 10 shots made. What you're going to do is you're going to go into Stat World again and edit, and I've put in L2, the bottom number, so all I need to do is put them in L1. So I'm going to go up to the top. I am not going to delete it. I'm going to hit clear and then hit enter, and then I'm going to type in those numbers. So it's 20, it's 18, it's 13, it's 22. If the camera cuts me off, you guys, I'm just going to have to live with that. We're running out of time on this, I think. 11, 17, 13, and 19. Okay? Now, I go into my stat plot second, and I go into this and I change it now to a scatter plot, and I make sure it's L1 and L2, and then I should be able to do zoom 9, and I see the points there. Okay, so I will draw that in, and then I'm going to find the best fit line. So I'm going to go stat. The best fit line over in calc is the linear regression line, number 4, and I hit enter. And I make sure it's in L1 and L2, which it is, and there's my linear regression line. I copy that down and I write it out. I can also try to patch it into the y equals menu by doing the following, by going to vars and then number 5 for stats, over to equation. This will save you time, and there it is. If I hit graph, there's the best fit line. Okay, what type of correlation is there? Okay, that is a positive correlation. How confident am I? And are they stringing up like a string of pearls? No, that would be 0.99 or 1.0 for 100%. This to me is approximately about 85% accurate. And I'm not going to grade you on how good you are at guessing. I want you to know if it's positive going up or negative it's going down, and then if it's like 100% or not, and it is definitely not 100% accurate. So I would say approximately any answer that's between 70 and like 90% is good. Okay, so I'm going to say about 80, I don't know, 85%. All right? There you go. Good luck.